Hello everyone, today I will walk through an analysis of a machine learning model developed to predict abalone age based on their physical attributes. And the reason why we do this analysis is that now the abalone farming is very ineffective for when determining whether or not the abalone is mature. Because now when after the abalone is collected, they need to be collected and sent to the microscope, and there are people counting their rings to determine the age. So it is inefficient, and that's the reason why we do this analysis. And here are all the packages we need, and this is the data of and the description of the data. So we have the length, height, and weight as the physical attributes of the abalone, and they are the independent variable. And we want to predict the rings of the abalone because they directly reflect the age in years. So let's do the data cleaning now, and we can see that we check the missing values, and there are no missing values in all the independent variables, and there are no duplicates. So that can help us to ensure the model's effectiveness, and all the unique numbers, and that looks normal. And after that, we generated some graphs about the data, things like correlation and distribution. From this graph, we can assume that the height of the abalone is not something that can grow very grow to a large number. You can see that the graph is very flat, and it might the abalone might are unwilling to grow the height because it might depend on the area they are in and nutrition like calciums they can get. And all other features, including length and weight, grow gradually together at the same rate, as you can see from the graph. And after that, we can take a look at the distribution of all the independent variable. You can see that all the independent variable have a similar shape. So except the height have some outliers, and I assume that's the two dot we see earlier. So that will not uh that will not have a big impact on our model. So we do not actually need to worry about those outliers. After that, we can take a look at the rings, which is the dependent variable, and the correlation with all the independent variable. So you can see that they all show a similar rate of correlation between each other, around 0.5, and actually the height also share a positive correlation with rings. So I will consider using all of the variables in the model. After that, we can go to and this is the outliers of the rings, which is the dependent variable. After that, we can uh, generalize the uh, datas to bring features onto the same scale. We used standardization and normalization to bring features onto the same scale. And after that, we used random forest to select the best performing predictors. And from the result, we can see that the shell weight is the best performing one, which is actually intuitive because it takes a long time for the abalone to gradually gain those weight. And the shocked weight, which is the weight of the meat, is at the second place. And all other features are at a similar level. So after that, we use several models to predict the dependent variable. Uh, Models like multilinear regression lasso regression, ridge regression, and like things like k-nearest neighbors were used to predict the dependent variable. And we used hyperparameter tuning and cross-validation to optimize these models. And we can compare the result between the predicted values and the actual values to select the best performing one. And this is the result, and I can tell you that the multiple linear regression and the lasso regression and also, sorry, the ridge regression showed are the two of the most best performing models. And I would say that the ridge regression is the best performing one because it shows the most balanced predictive performance. It mean squared error is 5.1, which is not bad, and it is actually the best performing one among all these models. And this is the graph between the prediction and the actual values. You can see that it has a trend like this, and the maximum error is 81%. So that is the best performing one. You can see that this one generated a maximum error much higher than that. So after selecting the best performing model, we can generate a learning curve. And here's the learning curve of the ridge regression. And we can, by analyzing this learning curve, we can say that the red line, which is the training error, starts relatively high and decreases as the training set increases. This indicates that with more training data, the model better captures the underlying patterns, reducing bias. And around 2,000 training samples, the training error slightly increases. This is expected because the model learns a more generalized pattern rather than just memorizing smaller sample details. The gap between the training and validation error is actually very small, and meaning that the model is not significantly overfitting. Based on the observed learning curve, the ridge regression model is well fitted because the gap between the training error and the validation error is very, very small. And for the next step, I think if we want to improve these models, by looking at the coefficient, we can by looking at the coefficient here, we can see that there are some negative coefficient. So that is something that I did not expect it in the model. So I would say I would look at into this coefficient and the corresponding independent variable, and I might consider remove some of these. And after that, I can add some polynomial features or interaction terms. Something like the shell weight and the shaft weight can be considered. That can capture a more complex relationship, I think. And additionally, some improvements such as tuning the regularization parameters by changing the alpha, we I think we that may help to refine the model performance. And I think this analysis is very uh, useful because it can help us to generate a calculation for the farmers. As soon as they capture the abalone, they can measure the weight, the length of the abalone, and they can, with a simple calculation, they can have a basic assumption about the age of the abalone, and they can determine whether or not to capture some of part of the abalone. And for some after the calculation, this might generate some ambiguous result. But for those, they can still send them to the microscope and determine whether or not to keep them or not. So it will help to improve the effectiveness of this farming industry. If uh, you know, helps a lot, I think. Thank you.